The broadcast is now starting. All attendees are in listen-only mode.
Okay, we'll start with the comparison with function programming today. Scala comparison with functional programming. Okay, many functional programming we have Python, Ruby, R. Okay, so Scala comparison with functional programming. Okay, functional programming means we have ready-made functions. Okay, more available, and we'll be using that functions in our business logic to achieve something. That's what it is known as a functional programming. Because if you compare today Python with any other programming language, Python is having bunch of functions already defined, though we have option to create our own user defined functions, but ready-made function is already present there. Okay, same concept Java, Scala, they also tried to bring, because in Scala also we have many ready-made functions, and that is the reason Scala support both object-oriented programming along with the functional programming. So first comparison is in functional programming language. In functional programming language, by default, by default, it support, any functional programming language support immutability. If you ask me what is mutability and what is immutability, I'll explain you this part. Immutability. Let's read again. In functional programming language, by default, functional programming language support immutability. Scala give choice to their user. I'll just tell you what is immutability and mutability. Okay. Scala gives choice to user. Gives choice or option to user whether they want whether they want mutability object to create. So by default, immutability is there. Okay, if you create anything by default, it is an immutable object always. If you want to create mutable object by your own choice, you can create it. Now, what is immutable and what is mutable? So immutable means you cannot change the value. Immutable means once you assigned some value. Okay, let's say I assigned integer a is equal to 10. Now this integer a equal to 10, so this a value is fixed for the entire scope. I cannot change the value of a. The value of a. So it's fixed for the entire scope that this is always going to be 10 only. Okay, that's what I call immutable. So in a Scala, to create an immutable object, there is a keyword defined. Okay, there's a ready-made keyword defined in the Scala, and that keyword is val. So we'll be using this val keyword to create anything. Okay, this what I'm writing currently, this is in Java terms. Integer a is equal to 10. In a Scala term, the same thing, I will write it as val a is equal to 10. And then semicolon, if you want to give, you can give semicolon. This is all optional in a Scala. If you're giving, that's okay. If you're not giving also, Scala will not complain you. So this all option is autocomplete by Scala programming language. Now, second thing, do you see anywhere I'm writing integer here in this line? In this line, this is in Scala. I'm not writing anywhere integer, right? So internally, my compiler will understand that this a belongs to integer because the value is 10. And it is storing somewhere this in JVM, Java Memory Management. Okay, so in Java virtual memory, we have a Java memory management. We call that a JMM memory model, where they keep this all the information based on this address. To check this address, there is a hash code function. So we'll call this hash code function to check the address. Okay, because we people we know English, so we can read this information by a variable called a. But how machine will understand this? Machine will understand with the help of binary and hash code variables. So if I read again this point number 1, it says by default, if you're creating anything, it is going to be immutable. But if you want to create mutable, you can create by yourself, and that is the option name is known as mutable object. Okay, your Scala journey will start from well, and second option is where, and it will end up here. So this is what you'll be creating every single time based on the application. Based on the application always. Okay, it's not defined somewhere that we'll be using well, this in this case we'll be using where in this case. Suppose you think that this value is never going to change, right? Suppose you are defining a pin code of any area, you know that pin code is not going to change. Suppose you're defining any ISD or STD code of any city, that is not going to change. So if you think that like pi value will always be 3.14, this will never change. So what do you think? Should I make this as mutable or immutable? Always I will make this kind of object as immutable, right? To define the value. We'll see this in the application. We'll see all this different example in the application side, that how we are creating it. Now, well A is equal to 10. Scala compiler is not complaining you, but my recommendation is not this. Scala does not complain you, that's another thing. But being a programmer, I will not suggest you to write this kind of code, because you are a programmer, you can understand it. Suppose I join a team after 2 months, and I am not getting what this A belongs to. So I should write the same information like this. Well, A colon, okay, A colon, and this column you will define later. So this A has a value of 10. This A has a value of 10, which is belonging to data type integer, which is belonging to data type integer. Okay, so A is equal to 10 now. Now here I'm specifically defining this A is belonging to integer data type. Okay, so I should write like this. This is my recommendation for you. When you practice, please define the data type, not just for this integer. Let's say you are saying, well, S is equal to Scala. You're saying, well, S is equal to Scala. Now, since you're writing this information in a double quote, so we know that double quote belong to string data type, right? So I should write there with a colon. People who are coming from Java, they find little difficult in the signature side, because this signature is different in Java. We write this data type, okay? We write this data type. So this is in Scala. If I write the same thing in Java, how would I write it? I'll say integer or string, right? I'll say there is string S is equal to Java. So we define the data type first in Java. This is in one programming language. This is in another programming language. So in Java, if you compare these two lines, in line number 1 and line number 2, I'm first defining the data type and then variable. Here I'm defining the variable and then the data type. That's the only difference. This is very concise part, okay? So logically, we should be clear. Once the logic is clear, we can see the syntax part later. That's not a problem. Because in any programming language, if you go, the syntax is always different. It's not same. So to make point number 1, what is your takeaway from here? Your takeaway that immutable I'm using well, mutable I'm using where. How I'm defining this, we'll see in the application. Then point number 2 after this. So let me call this as point A, point B, just to avoid confuser. Okay. Point number 2 says, in functional programming language, functions are first class citizens. Okay, so I'm trying to explain you in all layman terms. Functions are known as first class citizens. What do we mean by this specified idiom, first class citizens? First class citizen means we can play with the function. We can do this operations. First, function can call itself. Function can call itself. This is nothing but a recursion, or we call recursive function. Second point, function can call itself. Second point, function can be assigned as variable. Function can be assigned to variable. All this proof I will give you, okay, before after writing these points. Function can be assigned to variable. Function can be passed as argument to another function. So this is like all the grammar of a Scala. Argument to another function. Okay. This is how I can play with the function. Obviously, one function can call another function also. So fourth point, one function can call another function. Okay. So this is the four different things, and that is the reason I'm calling my functions are first class citizens. Now, point number third, it works with many other approaches like lazy evaluation. It has this lazy thing, lazy evaluation. This is one of the amazing concept, I would say. Okay, lazy thing. We'll see this in again programming, how we can write achieve lazy. Then we have features. This is by the way futures. We have futures. We have higher order functions. We have generic functions. We have lambda functions. Point number 6, it support closures. Then seventh, it supports multi-threading. So multi-threading we call in Java, or it's a general name. Multi-threading in Scala is known as a framework, akka. Okay, so akka is a framework. This is a framework of Scala. So these are the main points. Okay, 7 different points with comparison to functional programming language. These all things are allowed here. Now let's go and see the practical. Enough theory and concept we discussed. Now suppose you want to set this small thing, local thing in your machine. Okay, first you want to practice in Windows. You want to download the REPL file. REPL stand here for read, evaluate, print in loop. So I'll open the REPL first. You can do the same. You can go to here. and search it for Scala download. Okay, you just need to type this Scala download in inbox and get this file 2.11.8. 2.12.12, I feel that's a latest version, but don't go with the latest always. Go always one side lower for more stability. Otherwise, some compatibility issues are there. That's my personal experience. Now you have to download this file. You are using Windows, right? So you can download this file. For me, I have downloaded this file for Unix and Macintosh. TCZ. You guys can download this zip file. You'll have to unzip this, and after unzipping, you can open this using command prompt CMD in Windows. Okay, just type CD and go there and type go to bin, just like I'll open in my cell. So I'll search here for terminal. And here in this terminal, I'll go to my directory. So this is my current directory, users and username, CD downloads. Just this is how you have to go also to your directory. CD setup is Scala. Now I write lslrt. You'll have to type dir in Windows. I hope you know that to check the directory. Okay, then from here directly I can call this bin slash Scala. If this is not working for you in your machine, you can do one thing. You can go to bin first and then directly call Scala. Grab both this thing. So this works for me. I can access Scala from here. What I have opened is known as a REPL. This is for quick delivery. Once we understand the syntax, I'm only coming to this REPL to know the syntax part. Once this syntax is clear, we know how to write the program, then we will directly go to IntelliJ, which is our IDE. So this is for learning thing. This REPL thing is for just learning the syntax. Once we know the syntax how to write, we'll directly go to this IntelliJ and start writing the program. This is your main development area. This is like weapon for the developer. Okay. Now what I'm opening currently, this cell. The cell is like the same Spark cell which you open in Cloudera, typing Spark hyphen cell. Now, okay, so you type Spark hyphen cell, you get the Scala version. Spark is also there. Currently here we don't have any Spark thing, we just have a Scala plugins. Okay, this is Scala is there. So this is known as REPL, REPL. REPL stand for read, evaluate, print, and loop. Okay, this is what we call a REPL. We are reading, evaluating, printing, and we are repeating the same thing. Now I can use this as a calculator. I can use this cell as a calculator. I can say 9 plus 8 is equal to 6 into 5 is equal to. Okay, maybe let me see this. Oh, this is not working, factorial thing. But anyways, I can multiply, I can add these values and see the answer using the BODMAS rule. Now, if you're thinking, okay, this is good, but where we are storing the output of these values, where we are storing this output of the values, what I have seen, the first point, my first point is in functional programming language, it supports by default immutability. Scala gives choice to user whether they want to create a mutable object. Now, I'm not writing anything here. So all these values which are getting stored in a session variable. Session variable. Now, by the way, if I ask you a question, where this operation is going to store, Is it storing in a non-volatile storage, or is it storing in a volatile storage? Non-volatile means your disk, hard disk. Volatile means your RAM, which is temporary storage. So all this variable, this res0 is a session variable, this res1 is a session variable, this res3 is also a session variable. Session variable means they're only active till the session is on. Once I close the session, then this variable will go, because they are stored in a volatile storage. Can I access them? Can I access this res0 here? So if I type res0, you can access the actual value, which is again stored in a new variable called res4. So I'm using this basic binary operation or associative operation just to tell you that if you do not define anything, well or where, okay, by default it is always considered as a mutable object. Once you define, you cannot change it. Can I try to change this 17 to 18? It doesn't work. It gives me error, and that error is very clear, that reassignment to well is not allowed. And what is this well? This well is, we have seen, it's a immutable. Okay, so whenever you define by default anything, it's going to always be a immutable object. Now suppose I want to define immutable object using well. So can I write like this? Well, a is equal to 10. I can say this also. Well is equal to 10. And internally my compiler has understood that this a belongs to integer, because value is 10. If I write value d is equal to 10.00, then it will understand by default this is double. If I type well s is equal to spark, internally it will understand that this is string. Okay, similarly if I say well b is equal to true, it will understand this b belongs to boolean. So likewise I can handle my, suppose I want to create a float, I'll say f is equal to 13.00f, or maybe 90f. It will understand this is float. Okay, but my recommendation is not to write a program like this. You can understand since you're writing the line, but other people who are joining your project later sometime, they will not understand this code, what you have written. So we should specify this is integer, this is double, this is a string. I'll do that here. So specification is as follows. We'll say, well, a colon integer is equal to, then I want to write any value. Then I want to write, let's say 100. Now can I change the value of 100 to 101? This is immutable, I cannot change it. So it throws me exception reassignment to well. Okay, the same exception which I was trying with session variables. Then I should write this value as well d, and I should specify that this is double. And remember, one note I will add here, whenever you define any data type, okay, so data type first letter, data type first letter is always going to be in capital case, in capital. Remember this point. Whenever you are defining any data type, integer, double, float, string, their first letter is always in capital. Okay, can we try to make error and see what it says. So let me say this is D small case. And we should know the error also, how to read the error. If I type this, you can see it is giving me exception at the place of D. So since it is giving me exception at the place of D, I know that there is some problem in this word, and only the problem is with first letter, because this gap is coming only for the first letter. Okay, so this is how we'll read the error going forward, and we'll try to resolve it. So this is very simple error. It says not found, and we know that data type first letter is always going to be in capital. Similarly, I will write this Spark as, I hope you understand what I'm trying to say now. This is my recommendation. You should write like this always. If it is Boolean, you have to write this Boolean as B is Boolean, and whatever value you want to pass, false or true. We have two values in Boolean, true and false, 0 and 1. Similarly for float, if it is float, I'll have to say float. And remember always, whenever you are defining anything as float, you always have to write F at last. Always you have to write F at last. Okay, so this is like your value. Understand internally that this F, since I'm writing F, this is belonging to float values. Because if I don't write this 13.90, okay, and I try to submit it, so it is getting this point as double. It is getting this point as double, but here I'm writing float. That's why the error is very clear. Read the line number 2. Found double, this value is double value because I'm not writing F anywhere. Found double, but required float because you are typing this data type as float, right? So this is the error. We don't handle them well. So this is how we'll assign the value. Now can I use the operation, or we have not seen any where is where. So where thing is, I'll say where, and where p is equal to p, or maybe GDP is equal to, right, as GDP 2.9, and you know this belongs to double, right? So can you write double here? This GDP assigned as 2.9, and can I change this GDP from 2.9 to 3.0? This is allowed because this where thing is a mutable. Whenever you assign anything with this variable, this is always a mutable object. Mutable, again, we can change this value. We can change the value. And there is one question coming. Can I change the data type also? Can I change the data type from double to other? Okay, can I say this? GDP is equal to 3.0, or can I say just 3? Look at here. This is not allowed in Scala, Java, and most of the object-oriented programming languages. Once you define any value, okay, any variable, and you said that this is double or this is integer, their scope is fixed for the entire class that this is always going to be double. It cannot change to integer or a string. So we can change the value, but one more point I will write here. We cannot change the state. We cannot change the state. Okay, very important point to note here, because sometimes we confuse, since we can change the value, so we can change the state also. Statements we can change the data type also. That's not allowed in any OOPS programming. But the same operation if I do in Python, Python actually allows with this. Because Python do not have such compiler concept. Python has an interpreter concept. Okay, so Python will read this and change the value along with their data type also if you want to change it. But in Scala, we can only change the value, the state cannot change. Important point to note. I'll eat some operations. So I'll say op1 is equal to, well, op1 is equal to 2 plus 4. I can do this kind of operation. And obviously I should write the data type as integer. Now, can I add with this Scala? So I'll say, hey, I'm trying to concatenate, by the way, right? If you know concatenation, right? So this operation is known as a concatenation. Whenever we add two different string inter. What is the error? The error is coming because here it is integer, right? So I should change this to a string, and then definitely this will work. Hey Scala, it has done this concatenation, and we can see this op1 is equal to hey Scala. Similarly, I have many operations like this. Okay, so can I call some ready-made functions like uppercase, lowercase, drop, capital? Now, suppose you want to run some operation here, and in Scala there are thousand of functions. In any programming language, there are many functions. So you cannot remember all the function. So one trick I will tell you here: if you want to operate anything, you can say op1 dot tab. So when you use this tab, you'll automatically see all the possible options, that this many functions we can apply. This many functions we can apply in this variable, which is op1. Okay, so can I try with something? I will say 2 uppercase. So when I type 2, the suggestion I'm getting 2 lowercase and 2 uppercase. I will use uppercase and function sign. You can see all the values internally it has changed in upper. Similarly, can I call 2 lowercase? Everything is in lowercase. Okay. Can I call min and max function? Shortcut key is tab, Swapnil. Just op1 dot tab. Tab as a keyword in your keyboard. Tab button. So if you type tab, it will suggest you all these options. Okay, and we should be using this in IntelliJ also. There's a tab option. So if you give tab, automatically it will suggest you all the ready-made functions, which we can apply. Now, can I say op1 dot minimum? So min and max will not work here because this is a string, this is a character. Min and max will work when this is a number. Okay, numerical numbers. So we'll go to see when it is integer or long. So min max will not work, but can I try with something else? op1 dot, can I try with this? Min, okay, this is also not working. Anyway, op1 dot, I'll say take. This is important, I feel. Take 2. So when you say take 2, you will see it. My op1 is what first? Let's see op1. This is the value of OP1 A scala, and I'm saying take 2. So take 2 means take initial two letters. Okay, HE. If I say 3, it will take till Y. If I say just 1, it will take H. So this take is giving you the output which you want. Currently, I'm just printing it. Suppose I want to store this in another variable, I can say I can store this in another variable like where uh, n is equal to this, and I know this n is a string, so I should write this string, and I know this n is having the he. So if I want to operate this values, okay, I want to do some operations, I can store this in the variable. Now after where and this function, there is a function called drop also. Okay, so let me try drop here. How this drop thing will work? When you say drop, it will drop first 2 later. So take is taking 2 later, drop is dropping first 2 later. Now there's some capitalize operation. What capitalize does, capitalize will give you values after the number which you're writing. So this is the value of OP1, and you said capitalize 2. Capitalize 2 means this is 1, this is 2, this is 3. So it will remove, it will read, it is reading like a pointer. So it reads the third value after 2 point. Okay, because you have given here 2. So it will read this Y, 1 and 2. If I say 3, then it will read this blank. If I say 4, then it will read this S. So it works like a pointer, I would say. Just like pointer is going forward like a scale 1, 2, 3, 4, 5, 6, 7, 8. This capitalize is doing the same thing. If I want to read my values based on their position, then I can read using the capitalize operation. So this is operation with a string value. Can I check with numerical values, integers or long? So in long, I can in fact create this. Well, n1 is equal to, okay, well, n1 is equal to, I can write value like this, 1, 2, 3. This is one option. This is one option. Now how can I access, suppose I want to create a multiple element, right, at one shot, then I can do like this. I can keep in the bracket and write this value. Can I read this value based on the indexes? So indexes will not work because this whole thing, this is not a collection thing. If I type n1, then I'll read this out. Now can I apply n1 dot max, n1 dot min? So all this operation is not working here because this n1 is not a uh, list array map or set. This is not a collection type. So if I want to check the mean and max thing, what I should do, I will create where op2 is equal to, I can say 1 to 3, or maybe let me say 1 to 10. What do we mean by when we say 1 to 10? You can keep in the bracket if you want, or you can leave this also. So 1 to 10, when you say, it gives you a range. Okay, just like a range function, it gives you a range from 1 to 10. Okay, it gives you a range things from 1 to 10, and this is coming from range function. This is immutable type by default. This is immutable by default, right? And the value, this is, you're seeing this whole thing, okay, this whole thing from 1 to 10 is stored in a index called 0. This whole thing is stored in an index called 0, index 0. Now can I read this value? if I want to read this particular value, can I read this? Can I read this 5? So suppose if I want to read this 5, I will do this such operations. I'll say op2 dot op2 dot and dot, I'll go later, I'll see first index. So if I say 0, I'll get 1, because look how the indexing works. Indexing works always with this. So if this is my whole, one second, if this is my whole output, if this is my whole output, this is my index 0, this is 1, this is 2, this is 3, this is 4, 5, 6, 7, 8, 9. Okay. So indexing always start from 0. If you know, it's well and good. If you don't know, let me introduce another point. Indexing always start with 0. Length always start with 1. Length function always give you output from 1. Always start with 1. Okay. So indexing and length from 0 to 9. Now the next question is, okay, this is good. Can I access this 5, this 5 as a value? So I'll say op1, op2 and 4 here. So it will bring me that 5 output. Can I change this from 4 to 7? What do you think? It will work or not? This will not work. I will tell you before submission, because this is immutable. Always remember, always check this. If it is immutable, it throws you exception. Let me read this. In fact, when I submit this, the error is very clear. Value update is not a member of Scala collection immutable.range.inclusive. So this is saying that this belongs to the immutable type, and hence we cannot change it. So it's like I'm still on ABCD of Scala. It's like we're learning the alphabet. Now can I run some op2.min? This is the minimum value. In op2, if I ask you what is the minimum value here, you'll say 1 is minimum value. Similarly, can I check for maximum? So maximum will be 10. Okay. op2.max integer. But can I change this op2 entire and say 2 to 4? What do you say? This will work? This will definitely work because op2 is aware. This will definitely work because op2 is aware. Okay. So in initial days, we sometime confuse, okay, this is a fair question, that how this internal values I'm unable to change, but I'm able to change the whole thing. Because this internal values which you are assigning is immutable types. They are coming from a range function. Range itself is a immutable collection type. Okay, but since I have defined this op2 variable as where, I can change this. If this is well, then definitely this will also not work. Now my entire op2 thing has been changed. So this is one point, okay, which I would like to focus here, because this question comes often when you start writing program in IntelliJ, that how this is working and the second thing is not working. Always remember what operation you're doing. You're working with a variable or you're working with the functions. So far all cases. Okay, let me check the length also. I'll say op2.length. So op2 length is 3 coming because 2, 3, 4 is 1, 2, 3, and I think I have written some point that one second. I've written some point. Length always start with 1. So length always start with 1 means it will start eating from that point 1 to 3. Now after length thing, I will say couple of other operation. Let me say equality operator. Okay, I want to use the equality operator. So I'll say well A is equal to India and well B is equal to also India. But I'm changing the cases. You see, my first is upper, my second is lower. Now here if I want to check the comparison between these two, A and B, I'll use A equal to B. This is the equality operator. Okay. So we'll see a bunch of these operations in our comparison operators. Okay. We'll be using the 6 operators, by the way. Let me write all this. 6 operator. Operator number 1 is arithmetic operator. So we are so far in arithmetic. Arithmetic operator means this is the type of operators which we are going to use. Arithmetic means binary kind of operation, plus, minus, subtraction, multiplication, exponent. Then second is assignment operator. If I want to assign something like op2 dot op2 is equal to 2 to 4, this is what is assignment. I'm trying to assign values, right? Then third is a comparison operator. Then fourth is a logical operator. Then fifth we can use a special operators. Okay, so special operators means we have two types in a special side. Type number one is membership operator. And type 2 identity operators. So these operators are there in Python also. That's why I'm saying Scala and Python are very similar. Whenever it is required, I will always compare with Python. So you will see the difference between these two, very tiny difference, by the way. These are the operators which I'll be using. What do you think if I submit this equality thing? I'm trying to compare the operation number, the operator third I'm going to use. If I enter this, I'll get false because both values are not same. One is in upper I is uppercase and another I is in lowercase. So can I do this operation? Can I say A dot 2 uppercase and B dot 2 uppercase? If I try to do this, then what do you say? It will give me output as true, because why it will give me output as true? The reason is, okay, the reason is it is okay, one second. It is going to be all in capital. It is going to be all in capital, and here also all in capital. Enter this. So this is coming as true. Same thing, I can use a lowercase also. I'll get the same answer. Lowercase So all these operations are there. I'll strongly recommend today download this in your Windows and start working on these operations. Let's see a few more. Now, if I say, well, x is equal to 10, okay, and this is integer. and I'll say, well, y is also integer, and this is going to be 13. X is greater than y, false. X is less than equal to y, this will go here. X less than equal to y, yes, true. X equal to y, false. Okay, so this comparison we do often. We can use even if else condition also, like ternary operators. So I think this is good for today. We have seen so far till comparison thing. Okay, logical and special operators will be seeing tomorrow.